we're going to learn about, the sum and difference formulas. So, what I want to point out to these formulas, I kind of wrote them together so you can kind of see how they work. But these are called sum and difference identities. And we're going to use these to find, the sum of alpha plus beta. If we don't know what the angles are, but we can actually use them to find those little unknown angles like 15 degrees, 75. Because if you understand, we can find all multiples of 30 and 45. But there's like some angles in that 0 to 90 range, like 15, 75. The next quadrant 105. Those are one we can actually find all of those by using the sum and difference. So the sine of alpha plus beta, I want you to notice the formula. See how it says plus minus plus minus. If it's, if sine is positive, this is positive. Sine is negative, this is negative. What's kind of unique about cosine, if this is positive, this side's negative. That's why we write the formula that way. And this one's negative, this one is positive. Tangent, this is where people mess up. It's not that hard. People get scared because it's a fraction, whatever. But if you notice how if it's plus, the top will be plus, but the bottom will be minus. If it's minus, top will be minus, but the bottom will be plus. Okay? Now, one thing, a distinct thing, it's the same thing on top and bottom, but look at this. It says tangent alpha plus tangent beta, and here is 1 minus tangent alpha times tangent beta. And you almost always have somebody who will put a plus sign there. Okay? So those are the formulas I'll be using, and you can look at the notes and refer back to those. So we're going to need these skills. You need to know the 30, 60, 90, and the 45, 90. The few of you that like the unit circle better, great. But if you know it in the top of your head, great. If not, then this will be a much quicker method. So the quadrant system, we're going to use that to make sure we get the correct sign. Remember, everybody's positive in quadrant 1. Sine is positive in quadrant 2. The other ones are negative, sine and cosecant, but we're just going to be working with sine, tangent, cosine. Tangent's positive here, and cosine's positive here. Okay? So we're going to start off by finding sine of 15 degrees. Now, 15 degrees is clearly not on here, so I can't just find sine of 15. Like, I can find sine of 30 is 1/2. So, but sine of 15. So, you got to come up with two angles that either add up to 15 or subtract to 15. And they have to be angles I can find. Now, I wouldn't pick 20, take away 5, because I don't know 20 and 5. That makes no sense. So, what we do, a good one might be sine of 45 minus 30. Because I know 45, he's on this triangle, and 30 is on this triangle. So, now sine of 45 minus 30, if you remember the formula, this is sine of alpha minus beta. So the formula, and you guys could look it up, is sine of alpha, which is sine of the first guy, cosine of beta, and it stayed the same sign. If you remember, the sign was that. So minus, and then it's going to be cosine of alpha, sine of beta. Okay, so they kind of switch roles. So I have memorized just because I'm old, but you don't. I mean, we're going to let you guys have, typically in a normal year, we let you guys have all the formulas, but try to kind of learn them, as you can. No harm done. All right, so now I need sine of 45. Well, here's 45, sine of 45, 1 over root 2. It's in these formulas, it's much easier to use the cleaned up root 2 over 2. Okay, so sine of 45, root 2 over 2. Cosine of 30, so go to 30, rad 3 over 2. You do 5, 6 problems, you're going to have this all this trig memorized if you don't already, like you should. Cosine of 45 is root 2 over 2. Cosine of 45 and sine of 45 are both 1 over root 2 over 2. And then sine of 30 is 1/2. 1 over 2. Okay? So we can multiply this together. You got radical 6 over 4, radical 2 over 4. And we could put those in the same fraction if we like. Sometimes you'll find a textbook that likes to factor everything out. Really, it's no point in doing it. But right there is a good solution. All right. You're going to notice that almost all these solutions for all these 15s are going to look like this. They're all going to have that same look. We'll do another one and we'll see that. All right. So sometimes they're going to give it to you in radians. So let's say I was doing. They gave me cosine of 5 pi over 12. I don't have time for that. I don't have time for, to try to think of 2 radian angle. Let's just convert it. So this is actually 75 degrees. So since that's 75 degrees, I go, oh, okay, do 75. So now I can use 2 angles that add up to 75. Well, that would be 45 plus 30. Now, you noticed I used 45 each time. It turns out every single problem you could use like a 45. I mean, you could use 45 in something and that would pretty much always work. So these will be one of the angles would be in the 45 family and the other angle will be in the 30 family, all right? So 45 and 30. So the cosine formula is cosine of alpha, and then it says cosine of beta. Now, if you remember when I showed that formula, it actually switches signs. So this one will be minus sine of 45, sine of 30. So these 2 angles are always just going to go 45, 30, 45, 30. They're just going to go in the 2 locations, right? So you don't have to keep looking it up all the time. All right, now there'll be the same values. We just did all these. Cosine of 45, root 2 over 2. Cosine of 30 is root 3 over 2. Sine of 45 and sine of 30. Now it looks like we got exactly the same answers, but all that really switched was our sine and cosine kind of switched to 45, but they're the same value. So it turns out we got radical 6 over 4 minus radical 2 over 4. All right. Now, they give me the exact same answer. You're like, do they always give you the same answer? No, not at all. Well, why would that be? Well, if you think this through, I'm going to kind of draw right in here. If this angle is 15, this angle is actually 75 because they have to add up to 180. So actually 15 and 75 are in the same triangle. So if sine of 15 is that, then it's root 6 minus root 2. Sine is opposite over hypotenuse. You could actually do that. We could do Pythagorean theorem with this nasty stuff and get here. Well, this turns out to be, some ugly value, whatever. But now look, 75 degrees. What's cosine of 75? Well, cosine is adjacent over hypotenuse. So since the 2 angles add up to 90, then they have the same value. So sine of 15 is the same as cosine of 75 every time. That's why they have the same name. That's why they're called co-functions, sine and cosine. You hear the same name with the co, that means the angles will be the same when they add up to 90. So if I could find sine of 10, that's the same as cosine of 80. All right, that's what that's referring to. All right, I'm going to show you guys a tangent. So let's do tangent. I wrote down a problem I like to do. Let's do tangent of 345. All right, so tangent of 345. I mean, you're like, 345, that's way out there. Well, I can do tangent of 300 plus 45. So I could choose to do that. So remember I said I can always use 45, but there's a lot of them I can do. I can do, let's say, I don't know, 135 plus 210 that would work. You know, there's some multiple of 45, some multiple of 30. You know, those would work. And there's some other things we'll do. Let's finish this one first. So the formula for tangent, it said, remember, tangent of alpha plus tangent of beta over 1 minus. Remember, if this was plus, that's minus. This is where people mess up. Tangent of 300 times tangent of 45. I've, taught 33 years to where I've seen students, they'll put times and then eventually they'll just add. I mean, they'll put a plus there. And for some reason, they can't get that concept down. That's one of the tougher things for them. All right, now tangent of 300. You're like, I don't see 300. But remember with reference angles. So 300 has a reference angle of 60. If you think about 300 is 60 away. So all you have to do is look at this triangle and take the tangent of 60. So tangent of 60 is root 3 over 1. All right, but the thing is, I don't need a parenthesis, I'm not multiplying anything next to it. We're in quadrant 4. Remember 300. So you got to start thinking about what quadrant we're in. The last two problems I did, I was using 45 and 30 both in quadrant 1. So everything was positive, and I should have mentioned that. So tangent of 300, well, I'm in quadrant 4. I know tangent is negative down there, because he's only positive in 1 and 3, so he's got to be negative root 3. That's the only thing you have to memorize is, hey, what quadrant am I in? So it's only for the 300s. 45 is in quadrant 1. Everything's positive. So tangent of 45 is 1. I mean, if you use this, 45, opposite over adjacent, it's 1. That's one that's so useful in calc and everything. Tangent of 45, if you can memorize that guy's 1, he comes up all the time. All right? And just a little side note, tangent is slope. It's the same as slope, because remember, slope of a line is rise over run. So the tangent of the angle is the same as the slope, if you remember from Algebra 1, all those days of slope. So it's really useful that we can use the trig function of tangent to help us with, we can find the slope of if we know the angle of the line, we can actually find the slope. All right, so the root 3, well, what's nice about this formula, I don't have to look up 4 things. I already did the same things. I have a negative root 3 times the 1 there. Right? Now, how we clean this up, let me kind of write over here. I could rewrite that, whatever. I get that. That's kind of, it's an answer. It's just ugly answer. All right. So what we like to do, if you guys remember from probably, Algebra 2, IM3, excuse me, you would multiply by the conjugate. Because remember, we don't leave a rock on the bottom. So the conjugate would be 1 minus root 3, top and bottom. So if you remember, the conjugate's the opposite sign. So I got to do FOIL, whatever you want to call it. I got to multiply this all together on top. So I'm going to go ahead and do our double distributive property. Oops, my head was going too fast there. So I distribute there, and then here, the whole purpose of the conjugate is we get 1 outer and inner cancel, and then we do the last and we get minus 3. So 2 more steps. So I got 3 plus 1, 4, negative 2 over 3 over negative 2. Now, since the 2 goes into both of them, I can actually combine that in. And there's your final answer. If you want to rewrite the order, it's up to you, doesn't matter. And that's those 3, all right? On my next video, I'll do the other style of problems. We'll call it the part 2.